Hello guys, welcome once more to another video on our YouTube channel. So in today's video we are going to be looking at the entrance examination into the National Advanced School of Public Works Yaoundé, the engineering cycle, that is MENG. So we are going to be solving the mathematics 2021 questions, and we are going to be solving from question 6 to question 20. So about a year ago, that is last year, I did the solutions of the first 5 questions. So for those of you who are interested in the video, you can get to the video description of this video. You're going to see the link to that particular video. So if you're interested in it, you can watch. And I also want to thank you guys for always sharing the videos, always commenting, always liking, always giving me proposed videos to do. Okay, so the channel is at 2,500 subscribers, and it is all thanks to your efforts. So for those of you who are just joining us for the first time and able to like the video, share the video with your friends who are also preparing for the concours, subscribe to the channel, turn on your notifications so that when videos are uploaded you always be notified to come and watch. You can get to me on WhatsApp if you want to maybe purchase past questions of public works as well as their solutions. You can visit our website. If you need maybe a mentorship kind of or you need guidance, or you need more information about public works, you can get to me on WhatsApp, or you navigate through this channel and you're going to see a video I did that was explaining detailing everything about the school, from the concours to what happens inside the school. All right, so let's get started. Question 6. Let n be an integer, an even number. So logarithm to the base 2 of n, we have responses there. A is never an integer number, B is always an integer number, C can be an integer number, and D is always an even integer number. So first we are going to give the definition of what we call an even number. So an even number is simply a number that can be written in the form 2k. In this case, our k is supposed to be a natural number because our n here is supposed to be positive because of the domain of definition of logarithm to the base 2. The n here is supposed to be a positive number, so its logarithm will exist. So we are here talking about the positive even numbers. Okay, so if n is an even number, then it is in the form 2k, where k is an integer in this case. All right, so now we have to replace our n there with 2k, and then now we split by using the laws of logarithm. Logarithm to the base 2 of 2k is the same as logarithm to the base 2 of k plus logarithm to the base 2 of 2. But logarithm to the base 2 of 2 is 1, and logarithm to the base 2 of k remains logarithm to the base 2 of k. Now let us look for a condition that will make this result to be an integer. For the result to be an integer, what do we have? We have that our k here must be a power of 2. Okay, so that when we take logarithm to the base 2 of k, we are going to have logarithm to the base 2 of 2 to the power m. The m falls down and we get 1 plus m, because logarithm to the base 2 of 2 will give us we just give us 1, and we multiply with m. So you see that it is actually a conditional statement for this to be an integer. So option C is correct, can be an integer. Why are we saying can be an integer? Because for it to be an integer, there is a condition. So option A, which is saying that it's never an integer, is wrong. Why? Because if your k is 2, if m is 1, then k is 2. And for k to be 2, our n is going to give us what? Our n is going to give us 4. Okay, and if n is equal to 4, logarithm to the base 2 of 4 is normally logarithm to the base 2 of 4 is logarithm to the base 2 of 2 squared, which is 2. So it's an integer. That's a positive whole number actually. So you see that for this thing to be an integer, then logarithm to the base 2 of k must be an integer, since you're adding it to 1. Now for logarithm to the base 2 of k to be an integer, our k here must be a power of 2, such that when you replace it, the m falls down and you get 1 plus m. So you see that we are taking option C because of the word can be, because it is not in all cases that it is going to be an integer, but in a case where k is a power of 2, then it's going to be an integer. Alright, question 7. The function sine x plus 1, A, is periodic with period 2 pi minus 1. B, is periodic with period 2 pi. C, is periodic with period 2 pi plus 1. And D, is not periodic. So there are 3 things I would like us to note. The first is that if you have y, a function equal to r sine omega x plus or minus alpha, where r, omega, and alpha are constants, then the period is 2 pi divided by the magnitude of omega. The same thing for cos, but for tan, we have if y is equal to r tan omega x plus or minus lambda, where r, omega, and lambda are constants, the period this time around is pi divided by the magnitude of omega. In this case, we see that our omega is 1, okay, so the period depends only on omega. So omega is 1, therefore the magnitude will give us 1 because 1 is already positive. Therefore, the period of this function is 2 pi divided by 1, which is 2 pi. So option B is correct. The function sine x plus 1 is periodic with period 2 pi.